In this section, we shall introduce the Python programming language. And then we should start with variable types and basic operators. For the variable types in the Python programming language, we have numbers, strings, lists, tuples, and dictionaries. And for the basic operators, we have arithmetic operators like the plus, negative, divided by, modulo, floor, exponential. And for the comparison operators, we have this, assignment operators this, membership operators this, and identity operators this. So let's get started. Let's consider these variables which are created. In Python, we don't need to explicitly give the type of variable we are creating. In many other programming languages, you may have to say, for example, int the variable name equals, say, 6. And if you take this variable name to be equals a string later on, it's not going to work. Now in Python, this is not necessary. All you need to do is just give it a variable name. So in this case, we have this variable name equals 6. We can have another variable, say var2 equals this string. We can have another variable var3 equals, say, this list. We can have this list. And we could have another variable, say var4, which is a dictionary. So we could have this. We could have 1. We'll give you 1. We have here 2. And that. So no matter what we assign to a variable, the variable automatically gets its type from what is assigned to. And then just like any other programming language, we could print our data to the user. So here, for example, we could print out variable name. So we have variable name, and there we go. So we print out this variable name, and since variable name equals 6, we print out actually 6. Now there are ways of formatting this print function. You could put a message before the variable name, so you could have here the name of this variable, or we could say the content of this variable is equals this. So this message is in this double quotes, and then we have a comma followed by the variable name. And once we do this, we're gonna have this message, which is this. So we have this path which is coming from this string here, and then the variable name follows. And since the value starting this variable name is actually equals 6, 6 is printed out. Now there are also ways of formatting this. You could have, for example, the content is, and you could do this. So you have this curly braces, and then here you have dot format. Instead of this comma, you could put dot format. So we have dot format variable name. So we could have the content is of this variable. Now let's take this away. Let's take this is. And now you find that this is going to be replaced with this variable name. So there we go. The content is 6 of this variable. So because we put this curly braces, and here we put this format, dot format, we have this variable name in, and that follows. So we could always do this. We could have this other curly braces, and then we just make sure we put that in this other. So here, for example, we could put var2, and there we go. So the content is 6, comma, string of this variable, or we could say of these variables. So that's it. We could also continue, put in this, just making sure we keep the order. So here we have, for example, variable 4. So we have the content is 6 string and this of these variables. So that's actually how we format this print. And this print is very helpful, as it not only helps us see this data, but It's very helpful to in debugging your functions or whatever program you're writing. Now let's come back and look in more detail on these numbers. We're gonna look at the int and the float, as these are the two most common type of numbers we shall be working with in this course. We could declare an int like, say, number equals 5, and we have number, say, 1. Let's take this to be 2, and here we have number 1 equals 5. This number equals 8.0. Now once you have this, you automatically saying that this variable is of type float, and once you have this, you're automatically saying this variable is of type int. So this is an integer and this is a float. You could also have a long and a complex number, but we shall work with this and this now. So printing this out, we have print the number 1 is this, and the number 2 is that. So formatting this, we have number 1 and number 2. So there we go. The number 1 is 5 and the number 2 is 8.0. Then the second variable type we shall be working on is the string. For strings, it also suffices to define it with this double quotes. So once we have this, we could say our string, is this in the double quotes. And there we go. Now we thought, okay, yeah, we're supposed to give this the equal sign. So reloading, we have this, and we could print out string. So we have the string. And now what if we're interested in just getting this first element? Finding this first element, we have to note that in the Python programming language, just like many other languages, we start having this index from 0 instead of 1. So if we're looking for the first element, we're gonna have to select the index 0, and to select this index, we have to use the square brackets. So we have string of 0, which gives us this O. Now if we are looking for this element or this D here, we could count 0, 1, 2, 3. The space is also a character, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So we'll replace this with 26, and we have Z, and that's exactly what we do to get whatever character we have in the string. Now if you're interested in getting the portion of a string, say you're interested in getting this portion from this O to, say, this, you would have to use this notation. So yeah, since this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're starting from the 0th index to the 9th index. So what we'll do here is we have 0, we have this colon, and then we have 10. So since we're moving from 0 to the 9th index, we go from 0 right up to 10. Now actually what happens in Python is, if you wanted to go from 0 to n, so if you want to go from 0 to, say, n, you have to index from 0 to n plus 1. So here you're going to have the string outputted, but it's going to go from 0 right up to 10 minus 1. Or if you could consider it like this. If this is confusing, you could say, if you want to go from 0 to n minus 1, you will index from 0 to n, such that indexing this way, you're sure that you're going to have all the elements from 0 to n minus 1. Now, indexing like this, you're going to have all the elements from 0 to 9. So in this case, we're going to print string 0, string 1, string 2, string 3, string 4, string 5, string 6, string 7, string 8, and string 9. So let's print this out and see for ourselves. So exactly what we expected. Now we have this, our string up to this. Now let's fill this, because this may be because of the space. So let's fill this so that you could be reassured that what we have here is getting from 0 to 9. And there we go. We have this portion. And now if we add one element, we have from 0 to 10. So let's maintain this. Now, if you're interested in getting all the elements before 10, you could just do this and you have this. If you are interested in getting all the elements before, say, 15 or 18, you could have this. So no need to give the initial index. Now, let's say we want to get from the 9th index to the 18 minus 1th index. Here you're going to have 9. Now, unlike this ending index, because we have this starting index, which is in this case is 0, we have start index and we have end index. Generally, we are taking these elements from start index to end index minus 1. Now, unlike the end index where we go up to end index minus 1, the start index actually starts in whatever index we give it. So in this case, we're going to start with 9 and end at 17. So let's take something easier for us to count. Now we'll say we start from 2 to 7. So in this case, we're going to start from the second index right up to the sixth index. So let's do this before testing. So we have 0, 1, 2. We're going to start from here. So we're going to have 2, 3, 4, 5, 6. Because we have 7 minus 1. So we have this R up to this. So this is what we're to print out. So let's run this. And that's exactly what we get. Now, if you want to print right up to the end, it suffices to do this. Once you do this, you start from the second index right up to the end. And there we go. You could always find the length of the string. So you could print out the length of the string. So you have here 38 to tell us that the string has 38 different characters. The string too has other functions. That is other simple methods you could call. Like you could have string dot lower, for example. Doing this, you have this, or you could string dot upper. You're gonna send everything to uppercase. So everything here is sent to uppercase. Let's say we had this cure, so we could better understand when we send this to lower, find that the cure is then to a small cure. So everything is turned to lowercase, and that's exactly what we wanted. Now let's move to the next variable type. We're gonna work with the very versatile list. For list, for example, we could have list 1 equals, say 1, 2, 4. Now, lists are very important in linear algebra, particularly because they can be used to model a matrix. Let's first start by taking the simple matrix or the simple list, which can be seen as a vector. But then let's print this out and see what we get. So we have list 1, which is this. If you're interested in getting just the first element, you can have list 0. And we have that. We have this. And then we have that. Now notice that when we print 3, what we have is list index out of range. And that's because this list can only take 3 different elements. And once you print this, you're looking for an element which is not found in this list. And that's because the list has a certain number of elements it could contain. But then a list initially having a certain number it could contain doesn't mean it can contain many other elements. And that's why lists are very useful, because they can actually change form. They are very, very, very versatile. So we could have, for example, list 1 dot append, say an element 4 or an element 8. And you see now that this list 3 exists. Lists are not only made of numbers. We could also have lists made of strings. So we have list string equals this. We have 8, for example. We could put this string in list, and we have some other stuff, and there we go. So let's print out list string and see what we get. We have list string, and that's exactly what we get. So we find that this list can take in whatever kind of data type. We could have list string dot append, say hello. And printing this, we find that hello has been added onto the list. Now, just like with the strings, you could always have some particular elements of the list selected. So we could take from 0 to, say, for example, 2. Here we're going to take the 0th and the first index. And that's because we're going from start index to end index minus 1. So in this case, we have this. We see that we have the 0 and the first element selected. So we have 8 and this selected. Now let's take this 3, for example. We have the 0 to the second element selected. We have 8, this, and this. That's exactly what we wanted. Noting that at this point, list string is actually this. So there we go. Now, if you want to get all the elements from a certain index to the end, you could simply have 2, for example, and this. So printing this out, we have those elements from the second index to the end. So we have 0, 1, 2 from this right up to the end. We could always get the length of this list. That's to get the number of elements composed in the list. So we have print length string. That's it. We have 4 different elements, and that's because the string is made of 4 different elements. We also initialize empty lists as such. We could have an empty list equals this. So we just need to put these square brackets, and there we go. We have this empty list. Could print it out, empty list. So that's it. And also there are other ways of initializing the list. We could have matrix list or vector list, where we initialize it with all zeros. We could have 0 times number of elements, or we could have dimension of vector, where we could set dimension of vector to be equal, say, 6. And doing this, we could print out this is vector list equals this. And doing this, we could print out vector list. Now we see that this actually gives us just this list with one element 0, and that's because we've done this wrongly. Now, and correcting that, we have this put outside simply. So we have this, we cut this, and we paste here. So doing this now, we actually have the vector initialized with all zeros. And since this list can be changed, you could have vector list, say 0 to be equals 9. And you could print out vector list. And you find that this has become 9. Now let's see how to initialize a list to a matrix. We have number of columns, say equals 4, number of rows to be equals 3, and we can have this matrix list equals 0 times we have the number of columns, and then we have all this in this box times the number of rows. Now let's look at this again. We found that in order for us to have this, that is, we had this list initialized to 6 different elements with all being zeros, we needed to put this in the square brackets and multiply it with a certain constant, say 6, or a certain variable 6. Now in this case, what we're doing here is we're considering all of this to be that 0, and we're multiplying by this number of rows. So let's do this, and we have, say, print matrix list. So what we obtain here is this list made of these 3 rows. So we have this first row made of this 0, and this other one 0. as the number of rows equals 3. Now let's replace these zeros with what we had initially. So instead of this 0, we're gonna be having another stuff in here, but with another list, or replacing this 0 with another list. So let's redo this. Let's say matrix list initial equals this. So here we'll put a 0 times number of rows, and then here we have matrix list. Now we shall see how this other list is going to replace all the zeros. Let's print this out. Print out matrix list initial, and then print out matrix list. So we see here that this list made of 4 different elements replaces this 0. This other list replaces this 0. This other list replaces this 0. And this can be seen as some sort of matrix where these are the rows of the matrix. So we have this row 1, row 2, and row 3. Now a tuple is similar to a list, but the difference is that once a tuple is defined, it cannot be changed. So if we have this tuple, let's call it tuple 1 equals this, and instead of the square brackets we have the simple brackets. We have, say, 1, 2, 3. We'll print this out, tuple 1, and then we could try to change its values. Say tuple 1 0 equals, say, 9. We find that we have an error. Tuple object doesn't support item assignment, so it's actually different from list in this, as its values can't be changed. So that's it. We also have dictionaries. Now let's give this dictionary 1 equals, so we have this. We could copy this dictionary we had defined earlier. We have this here. And there we go. Now to obtain some elements, you could print out dictionary 1. To obtain the element with 1, we have this. We see clearly that once we specify that we want this element whose value is 1, it gives us its value. And once we have the element with value is 2, it gives us its value. Now if you keep on doing this, you go to 3, find that we're told that this 3 doesn't exist. So actually this is some sort of key value pair. So these are the keys and these are their values. Keys and their values. That said, let's look at the Python operators. We have the arithmetic operator, the comparison operator, the assignment operator, the membership operator, and the identity operators. So let's look at the arithmetic operators. We could have, say, a variable a equals 5. We have b equals 7. We could have c equals, or we could take this, add, let's say add equals a plus b. Let's say subtract equals a minus b. We could say divide equals a divided by b. We could say we have power equals a to the power of b. We have modulo, which is equals a modulo b. So we have a mod b. We have lower divide equals a divided by b. And now we could print all of this. So we have print add, print subtract. Now let's change this to, say, 15. So we have print add, print subtract, print divide, power, lower divide, and there we go. So let's get the answers. We have, for this first case, we simply add these two variables, 15 and 17, and obviously gives us 22. The next we subtract, the next we divide, and that's why we have this float. The next we take to the power, so we have 15 to the power of 7. This gives us this number. The next we have the modulo. Now 15 mod 7 is actually equals 1, and that's because 15 divided by 7 is equals 2 remainder 1. And we know that with a mode, this is actually what interests us. So that's why here we have a 1. And the lower divide actually collects this. So once we divide this, this is the lower divide, and then this is a mode. So that's why here we have 1 and here 2. Now let's look at the others. For the comparison operators, we shall look at this more in detail when we shall be dealing with conditions. Let's look at the assignment operators. For this, you could have, say, A equals 8, you have B equals 5, and then you want to say add C equals C plus A. Now, if you have this, or let's take B, let's say B equals B plus A. Now if you print B, see that you have 13. That's because A is 8 and B is 5. Now instead of doing this, you could replace this with plus equals. So doing this gives the same answer. So this plus equals is actually equals, or this is the same as doing this plus this. So B is equals B plus A is the same as taking this. So if you want to subtract now, if you want to have B equals itself minus any other variable, you could simply do this. For the multiplication this, and for the division that. So that's it. Now let's look at the next. We have, for these other operators, we shall see this when we shall be working with the conditions and the loops. So that's it for this section on variable types and basic operators.